Hello, everybody. This is Sunday. It's January 8th, and we are about to begin our course on elementary astronomy online, Astronomy 1040. I'm Dr. Brad Carroll, and I'll be making these videos every week for you, giving you a preview of what is in each of the 14 modules that make up the course. I'll let you know if there's any astronomy news going on, and I'll always end by showing you what's in this week's night sky using stellarium. The videos are about 15 minutes to half an hour each, so I hope you'll watch them. Now, let's get started here. We are going to start talking about astronomy. And it's hard to know who the first people were that looked up into the night sky and wondered about what there was up there. And we have so much of our night sky polluted by stray light from electric lighting that we don't know what it would be like to live in a world that was lit only by fire. And it probably would have looked something like this. This is a picture I took back in 2016. I was up at Lassen Volcanic National Park in Northern California, and I was camped on the shore of Summit Lake. And in fact, right here over my shoulder, you can see the little glow. That is a tent that was it's a lantern that was in our tent. But we went outside and oh my gosh, the stars were just amazing. And this is a picture you can see behind me here, there's the Milky Way up in the sky, the stars, and everything is reflected in Summit Lake. And it was just a beautiful, beautiful, beautiful night. There's also two planets in the sky. You can see right here is Mars, and over here is Saturn. So early people would have seen something very much like this, and they would wonder, what are we looking at? And that's what this course is about. To answer that question, what are we looking at and how do we know? So I hope you'll enjoy learning all about this. So what can I tell you about the course? Well, first of all, we're going to be using different units that you might be used to. That means we're going to be using the metric system because that's what all astronomers use. And it's not going to be a big deal. You're not going to have to do conversions or anything, but we'll be using meters as a unit of length. And a meter is about a yard long. So if you want to think about a yard being a meter, that's just fine. Now, you may know that sometimes we measure distances in kilometers. And a kilometer, kilo, is a prefix meaning 1,000. So a kilometer is 1,000 meters. It's about 2/3 of a mile. And we'll be using other units to measure distances in astronomy because the distances in astronomy are vast. And to just use meters or even kilometers, we'll find out is just too short a unit. And so we'll use, for instance, an astronomical unit. We'll use that to measure distances within our solar system. And one astronomical unit, abbreviated to 1 AU, is just the average distance between Earth and the sun. So how far away is the sun? It's one astronomical unit away by definition. Mars is about 1.5 astronomical units away from the sun. Venus is about 0.72 astronomical units away from the sun. So we'll be using that. For greater distances, we'll be using light years. And that is the distance light travels in a year. And a light year is a very large distance, but we'll see later that even for the distant galaxies in the universe, light years is too small a unit, and we'll use larger units than that. And by the way, an astronomical unit is about 1.5 times 10 to the 8 kilometers. That's 1.5, and then but about 7 zeros after that. And how about a light year? A light year is about 9.5 times 10 to the, look at my notes here because I don't have it memorized, 10 to the 18th kilometers. Huge numbers. Now I'm saying things like 10 to the 8th, 10 to the 18th. So we'll be using powers of 10 notation. So please look at how to use that. And please read the introduction to the first module, because in there I have some exercises about how to use powers of 10 notation with your calculators. Now, one of the main tools that we use to study the stars is mathematics. And we use mathematics to make sense of what we're seeing. And so there will be some math in the course, but don't worry about that, because all the math you'll see will be on your homework. There will be almost no math at all on the exams, because I want you to see how astronomers know what they know. And so nobody has ever complained about the level of math in the course. So powers of 10, take a look at that. And please take a look at the introduction to the module, and you'll go through some exercises of how to use your calculators with that. And there's also some online calculators you can use. There's lots of resources in this course for you. So there also is going to be special words in the course. And so we use a different vocabulary, and sometimes we'll use words in a different way than you're used to. And in the introduction to Module 1, you'll run into some of those too. Words like hypothesis and theory. You know, hypothesis to a lot of people means, oh, I'm just going to make a guess. But no, in science, hypothesis means it's an idea about how something works that can be tested. And so to have a valid hypothesis, you have to be able to prove it wrong. If you can't prove it wrong, no matter what you do, then it's not part of science. Also, theory. You know, sometimes people say, oh, that's just a theory. You know, sort of what they really mean is, oh, I don't believe it. But in science, the word theory means it's a self-consistent collection of ideas that have been thoroughly tested. And they describe our best understanding of how the universe works. So theories are the ultimate aim of science. So take a look. That material is also in the introduction to Module 1. You know, sometimes in these modules, I will put something that isn't in your textbook. And so be sure and take a look at that. Speaking of your textbook, I hope you have it by now. Here it is, Explorations by Arne and Schneider, 8th edition. If you can, you know, if you have an earlier edition, that should work just fine for you. The page numbers may be a little bit different, but I'm sure you can figure it out. There's a 9th edition you can have, but that only comes in loose leaf. And they did that so you cannot sell your book back. And if you are somebody who sells books back at the end of the semester, then you're not going to be able to with the 9th edition. So that's why I'm sticking with the 8th edition for now. Okay, so I think we're ready to start talking about what we see in the night sky. And you know, there are regularities in the night sky. And it's important, let's first orient ourselves in the night sky. And if you were standing where I was standing, looking toward my campsite there in the background, I would be facing south. So I want you to just pretend that you're outside facing south. You're outside facing south. Now, suppose you point to the left. So go ahead, point to the left. Which way are you pointing? Go ahead and look to the left. Oops, there we go. Look to the left. You're looking east. And so that means when you're looking south on the screen, east is over here on the left side of the screen. Same way, if I point right, and if I look right, then I'm looking to the west. And so that means the west is over here on the right side of your screen. So what is the first thing we notice about the stars? Even the earliest people looked for regularities in the sky. And they would find that stars would rise in the east over here. They would go over, cross the sky during the night, and set in the west. And for a long time, they didn't understand why that was. You know, people thought, well, heck, if Earth was rotating or moving or something, I would feel it. No, that's wrong. But that's what they thought. And so they thought the entire sky moved around them, with stars rising in the east, moving across the sky and setting in the west. Today we know it's really Earth that's spinning on its axis like a top. And it spins from west to east, and so we see stars come up in the east and set in the west. But that's because our Earth is rotating. I noticed other regularities too. If you look at the moon goes through a series of cycles. It goes from a new moon, where there's no new moon in the sky, to a first quarter moon, where half the moon is lit up, then the full moon phase, and then the third quarter moon, and then new moon again. So the moon goes through a series of phases, and we'll find out exactly why that is in this module. So we'll see the origins of lunar phases. There's also some videos that you should take a look at. So take a look at those videos, and that will help you understand moon phases, I think. Also, every once in a while, the sun and the moon and Earth will all line up in a straight line. And it so happens that if the moon comes between Earth and the sun, the moon can blot out the sun's light. And that's called a solar eclipse. On the other hand, sometimes Earth gets between the sun and the moon. And in that case, Earth's shadow falls on the moon, and that's called a lunar eclipse. And you'll learn about those in this module as well. Now, speaking of the phases of the moon, that's what your first observing project is about, the phases of the moon. And it takes about 6 weeks to do, or 5 weeks. I give you 6 weeks just because, you may start a little bit late. But you have a moon calendar. I want you to go out every couple nights and take a look at what time it is, take a look at where the moon is in the sky, and just make a moon calendar that shows how the phases progress as we move through the month. I know some nights it's going to be cloudy. That's okay. Just draw some clouds or something like that. But you should get plenty of opportunity to see the moon. Now, the full moon was just 2 days ago. And so this is a good time to start your moon calendar. We're going past the full moon. And that means you're going to have to see the moon either late in the evening, or early in the morning, because the moon's going to be rising later and later and later. So take a look at that. And by the way, the observing projects are optional. You don't have to do a single one. You can get 100% of the points for the course without doing a single observing project. But the observing projects are for extra credit. And if you want to do one, for each one you do, you get 1 point toward your total score in the course of 100 points. If you do 10 of them correctly, you get 10 points, and that's a full letter grade. So take a look at those. I hope you'll give those a try. So what is going on in the sky right now? I want to show you something. And this is a little bit of recent astronomy news. And that is a new comet has been found, a new comet. A comet, we'll find out, is a dirty snowball of ice and dust. When it gets near the sun's rays cause the comet to glow. And this is comet was discovered in 2022, and it's named 2022 E3 ZTF. The ZTF is for the Zwicky Telescope Facility, which was the instrument used to discover it. And it is getting closer to the sun. It will be at its at its minimum distance, its closest distance to the sun in a couple days. And then as the month goes on, as January goes on, it will be coming closer and closer to Earth. And so in about 2 weeks, if we're lucky, we'll get a good view of this comet. Comet 2022 E3 ZTF. Just rolls off the tongue. Now, right now, the comet is too dim to be seen with the naked eye. But I hope that as it approaches the sun and it loses more and more of its material, so it looks larger and larger and brighter, that we'll get a good view of it. Comets are notoriously hard to predict. Sometimes they fulfill their expectations. Sometimes they just fizzle out. But in about 2 weeks, I'll show you where to look in the sky to see it. But for right now, I want to take a look at what's in the sky tonight. And so I'm going to pull up Stellarium here. Stellarium is the free software that we'll be using. I'll be showing you scenes from Stellarium every week, and you'll be using it for some of your observing projects. So here's Stellarium. This is Stellarium's view of the night sky. This is what it would look like. You can see up here is the time and date window. And this is for the 10th. And so this is going to be Tuesday night at 2300 hours. So this is at 11 at night. And we're facing south, as you can see down here. So facing south, we can look at one of my favorite constellations of all. It's the constellation of Betelgeuse. I'm sorry, that's the star Betelgeuse. It's the constellation of Orion. So here's Orion. Here's the red giant star Betelgeuse. Here is the white hot star Rigel. Over here is Ursa Major, the big dog, and that is Sirius. It's the brightest appearing star in the sky. It's not absolutely the brightest star, but it's very close to us, and so that's why it appears to be brightest. And if you're facing south, you can look up from there, and you'll see the planet Mars. So right now, Mars is in the sky. And also, two of my favorite star clusters. And in fact, these are two of the star clusters that you will have to know for your constellation quiz at the end of the semester. Right here, the star cluster is called the Pleiades, the Seven Sisters. And it's really prominent in the sky. So if you look at Mars, just look to the right of Mars, a little bit toward the west, and you'll see the Pleiades. And down below here is another red giant star called Aldebaran. It's in the constellation of Taurus. But the stars surrounding Aldebaran form the Hyades cluster, Hyades. That's the other cluster you have to know. So if you go down to Orion, look at the 3 stars in Orion's belt, just go up from there, you'll run into the Hyades and then the Pleiades. And that's how to find them in the sky. Now let's go back down here. Again, east is to the left side of the screen. So I'm just going to drag the screen over here to the left. And we can see the moon. There's the moon rising in the east, as do all the stars. And there it is. And it is in the star Leo. I'm sorry, it's in the constellation of Leo. Here's Leo. Leo looks like sort of a back question mark right here. There's Leo. And Leo the lion, that is the head of the lion. Here's the body of the lion and the lion's hindquarters. So there's Leo. I can put up the lines for Leo. So you can see Leo right there. And so right now the moon is in the constellation Leo. And you might wonder, well, how do I know, what constellation something is? And let me just show you here. I'm going to throw the constellation boundaries up. These red lines mark the boundaries of the constellation. So anything that is in this region right here outlined by these red lines is in the constellation Leo. The constellation Cancer is up here. And anything in this area is in the constellation of Cancer. Who says these are the official outlines? I mean, who says, yes, this is what they are? It's the International Astronomical Union. And that is a collection, an organization made up of the world's prominent astronomers who vote on things like this. So astronomers all over the world can agree on these things. There's an introduction to stellarium in your, it's a video, it's on the course homepage, and I hope you'll take a look at that because it tells you how to use this amazing piece of software. So that is what's going on this week. I hope you'll take a look, watch the videos that are part of the course, read your text, look through the course material, and I think you'll enjoy learning about this first part of the course. The first two modules are about the history of astronomy and how early people, how early civilizations, the early Greeks and so on, tried to understand what they were looking at. As usual, if you have any questions about anything, you're always welcome to send me an email. I'll be happy to set up a meeting with you either in person in my office or by Zoom. So let me know how I can help you out if you have any questions. And until then, I hope you enjoy learning about this, and I'll look forward to seeing you next week. So until then, bye-bye.